ahead and get started. Thank you all for attending what's going to be our second part of kind of our AI and DevOps. I'm sure we'll have some other things kind of around AI over the coming months, but thank you all for being here. Appreciate it. Wanted to kind of kick us off. Again, my name's Jeremy. This is the DevOps KC Meetup. And before we get started, I want to have Alyssa from Tech Systems just come up, give us a little spiel on what Tech Systems does, and who they are, what they do, and they're kind of sponsoring us with the food and with the space. So thank you.
Yeah, of course. Thanks for the kickoff. I'll start off. Who all is familiar with Tech Systems? You've heard of us. You've worked with us. Cool. I see some familiar faces here. So the people that I have met before, it's really good to see you in here again. Like Jeremy mentioned, my name's Alyssa. I'm the digital and creative account manager with Tech Systems. We're a IT services and business company. So essentially we work with 80% of Fortune 500 across the nation. A lot of companies here in Kansas City. We work with customers to fill their open opportunities, and we work with candidates to get them in the right opportunity themselves. So after we do wrap up here today, if you haven't already, there's some snacks and some drinks in the break room. But we will be doing like a little bit of like a networking situation afterwards. Rachel, wave, smile to the people. She is our recruiter that is specialized more so within this space. So if you guys are on the market, wanting to network a little bit more or just hear a little bit more about the marketplace, she's going to be your go-to gal. But after we wrap up here, we'll have some networking. And if anybody has any questions, find one of us and we're happy to help you out.
Cool. Yeah. Thank you.
Thank you.
All right. How many of you, this is your first time to a DevOps KC Meetup? Excellent. We still keep getting more people coming. That's great. Glad you all are here. We are kind of one of the things we've been doing over the last 5 months is as we kick things off, seeing if anybody has anything in the community that they want to kind of share, maybe something that's upcoming, maybe an event or another meetup that they're associated with, or some type of thing like that. If anybody wants to kind of share anything, bring it up.
July 27th, Next5.io is having an all-day futurism conference, so AI, biotech, a little bit of everything coming up in the next 5 years. So anyone that's interested, come see me and meet me in the networking area. I'll tell you all about it.
Where the food and drink is afterwards.
Exactly.
That'll answer questions. Cool. Excellent. Anyone else? Yeah.
Is anyone going to FutureCon next week? Anyone heard of that?
What is FutureCon?
It's a security conference in town. I hadn't really heard about it, but like people on LinkedIn reached out to me, and so I'm going. I guess next Thursday, I think it is.
Okay.
I think it's a paid event, but I got a ticket somehow. So yeah, I don't know. Anyone else heard of that?
So everybody should check their LinkedIn DMs.
Harvest your organs, or yeah, just you always have to be cautious around LinkedIn spam.
With Bernard's.
Cool. All right. Anything else?
KCDC is coming up.
That was gonna be one I was gonna mention. Good. Yeah. KCDC.
Who's also going to KCDC this year?
Couple. Yeah. KCDC is great. It's June 21 to 23. 21st is all-day workshops, or half-day and all-day workshops, and then the 22nd, 23rd is that Thursday and Friday. Those are the correct dates in June. Really great conference, up to about 2,000 or more developers from this region. This was the Midwest's largest conference of that sort. So definitely check that out. It's kcdc.info, I believe, is the website, or
KCDC.info.
yeah, or KC_DC on Twitter has info. But definitely check that out if you can. Tickets the early bird is gone, so now it's regular price. But they do have a thing there if you want to get your manager to pay for it. There's a letter you can put your name in and send it to Rob. So, anything else? Anyone else have anything to add?
I think Interface KC, is that the name of it? It's coming up in July, I think July 13th, also at the Overland Park Convention Center.
Cool.
Not sure any details on it, but I think I'm going to be there for the community table.
Interface.io, is that you said?
It's Interface KC. I think you just Google Interface KC and you'll end up there.
Okay.
Isn't that what it's called?
Yeah.
Yep.
Interface KC. Okay. Coming up.
June 9th.
June 9th.
Wait, never mind. That was a couple years ago.
I had June 13th in my head.
July 13th.
July 13th.
July 13th.
Okay, so July 13th, Interface KC is coming up. Okay, anything else? All right, with us tonight, we're going to have Aaron Blythe. Aaron, if anybody doesn't know, Aaron's been around in the DevOps space and in DevOps KC, DevOps Days KC for many, many years. And so glad to have him join us tonight to speak on AI, generative AI, and LLMs. So with that, Aaron, turn it over to you.
All right. It's kind of exciting. We had our first DevOps meetup on April Fool's Day, 2013. So it's been over 10 years now that we've been getting together for this meetup, which is kind of exciting. So do I need to do anything to turn on this mic, or is it ready to rip? All right. Hit my reset. All right, let's do this. We're here to dig into two different questions today. The first one is, what is generative AI? Or you'll hear me say just Gen AI, because I like to save syllables. Generative AI is a branch of artificial intelligence where the AI creates something new. And this could be like text, or it could be an image, or a video, or basically anything that's bits and bytes. So I want to watch a recent commercial from Coca-Cola that they created using Stable Diffusion and a lot of other things. And this is both like image and AI creation. Maybe. No? I might not be on the Wi-Fi. Is there? Actually, I guess I probably should have checked that first. There we go. Do I have to do the test thing? So since this is a DevOps meetup, I'll show you the trick I usually do, which is 1.1. No internet. Interesting. Let's go off my my iPhone. All right, we'll come back to these videos if we can get to them later. So second question is, what are large language models? Large language models are AI models that are trained on a huge corpus of text. And we've seen a lot of these very recently, mostly this year. And they've shown this incredible emergent behavior. So perhaps you've already used like Bard or ChatGPT, and these are the chat versions of large language models. However, I want to dig in quite a bit deeper on what these are today. So first off, who am I? My name is Aaron Blythe. I recently completed a master's degree in computer science with a focus in machine learning from the University of Illinois at Urbana-Champaign. Thanks. After that, I completed a certificate in business strategy from Harvard Business School. And I've also passed 18 certifications in cloud-related technologies over the last few years. And I share all of this, of course, to brag, because that was an incredible amount of work, but also because I believe that these are meaningful to my background to speak on this topic. I use a hashtag of continuous learning on LinkedIn that I'm aware has over 200,000 views, and the tools to count this are not the greatest, so I just know it's over 200,000. And on this hashtag, I share the accomplishments, the things that I've been doing learning, but I also like to show like motivational things such as this, because I believe that like small amounts of effort repeatedly over time produce like shocking results. Like if you just put in a little bit of effort and spend an hour a day learning, you can actually work your way through a master's degree, even having 3 children, right? And I often end posts with, please, as always, reach out if you believe that I can help in any way on your journey. And the conversations I've had from this are incredibly rewarding. I've had a handful of meaningful conversations. One actually was with someone that I've known for a long time, and they were on a journey where they were the line manager in a manufacturing company, and started talking to me about the goal they had of becoming a scrub master. And usually these conversations I've had involve getting one of these type of certifications. And he did it actually over a 6-month conversation, over text, over phone, over LinkedIn. And it was life-changing money for him and his family. Like not quite double what he was making in his previous salary, but quite a bit, like absolutely life-changing for him. So I think that those of us in tech should be doing this and reaching out to people to actually like uplift people to do the kind of things that we're able to do, because it's so awesome. I don't feel like I have a job. I feel like I get to play all the time. This is beautiful art that Canva created when I prompted with just, these ideas are my own, right? So this is my disclaimer page. These ideas are my own and do not reflect my employer, who happens to currently be Google Cloud. Everything that I'm sharing is public knowledge, and the links are provided directly on the slides. My examples shade towards Google and University of Illinois, mostly because those are the things that like I follow in my feeds. So since the beginning of the year, I paused all of my coursework and certification study to instead study generative AI. And there's not really courses. It's not like you can just like pick up a course. Only recently, in the last couple of weeks, have things been showing up on Udemy and Udacity. And what I've done for you here today is to organize the questions that I have about artificial intelligence. And in some cases, I've tracked down the answers. And in other cases, I've just got more questions from the questions that I've been asking and trying to find the answers to. So it's my aim to explain this as visually as possible, with as little math as possible, despite my own personal love of math. And the top 3 level questions are, first, how did we get here? Where are we at right now in 2023? And where are we going? So first, we're going to start with, how did we get here? And with nearly everything in this space, we start with Alan Turing. He actually coined the word computer. Many attribute his code-breaking skills to shortening World War II by a couple of years. If you haven't had the opportunity, you should watch the documentary Codebreaker or the Benedict Cumberbatch movie, Imitation Game. His life met a very tragic end because of very awful people. But Turing gave us a test in 1950 to determine if a machine is intelligent. If person C passes a note with a question to the other side of like some type of curtain or whatever, then either a human will write down the answer to that, or a human with the aid of a machine will ask that question and the machine will answer it, and then we'll pass it back to person C. If person C can't correctly determine whether that response was from a human or a computer, and it was from a computer, then we have artificial intelligence. The second important thing is Moore's law. And this is an observation that the number of transistors in an integrated circuit doubles every 2 years. But like more generally, like, the way we say that anymore is that like computers get twice as fast every couple years, right? And that's held true well past like integrated circuits or whatever, even though we don't call them that anymore. Now this is a logarithmic graph, so this is actually exponential, but because it's on a logarithmic scale, it looks very linear, and this is held true for some time now. We always talk about Moore's law being broken or whatever, and then some new breakthrough happens, and it continues on. Another thing that's been growing exponentially is the use of cloud computing. Cloud computing has all kinds of important attributes. The ones I want to focus on here is only paying for that compute that you use, because a lot of AI is very compute hungry. It just eats up compute like crazy. And the other piece that's important is that compute can be used in parallel. So I can use 100 computers for one day, or I can use 2,400 computers for 1 hour, and that's going to cost the same amount. So if I can parallelize my problem, I can solve it in a ridiculously fast amount of time. In biology, neurons were first discussed in 1890, so it's been over 130 years, and this model's been refined continually over that time. What we know is that there's electrical impulses that fire across synapses, and what synapses are these junctions between like two cells with this very small gap. And if we put many neurons together, that's how we complete a thought. So the idea of neural nets has been applied to computer science. And again, we have Alan Turing to thank, this time in his 1948 paper on intelligent machinery. He didn't actually use the word neural networks in this paper, but he did actually use the word neurons to describe the A-type and the B-type unorganized machines. So the research on neural nets started with biology. It started with the visual cortexes of cats, actually. And when we do a convolutional neural net, we use multiple layers. So in the 1980s and 1990s, there was a lot of talk about how these convolutional neural nets were amazing, but we didn't have the computational power yet because Moore's law didn't reach that point, and we hadn't networked computers the way that we had networked them in the cloud. But around 2010, this picked up. So a fun toy problem that's been around for some time, I pronounce it CFAR 10. In this problem, there's like 10 classes. There's birds, dogs, trucks, all kinds of different things, and there's 60,000 images. And all of them are 32 by 32 pixels, and they're in color. What a convolutional neural net does is with all of those layers that I was showing earlier, it finds things like the edges of there's like dark right next to light, and it considers that to be an edge. So for a bird, if it started to see a circle with a little triangle for a beak, it would predict, okay, that's a bird, eventually, right? Not right out of the gate. So there's and I'll get to that because that's back propagation. There's an ongoing competition for accuracy on the CFAR 10. In 2012, we were at 90% accuracy. That was the top of the line, the best model possible 11 years ago, right? So just this year in 2023, that model, the best model in the market, got to 99.7. This actually beat the best model prior to that from 2020, which was 99.5. When I was in doing my master's degree, I got a model up to 79.8% accuracy, training just for like about 13 minutes on Colab, which is this Jupyter notebook you can use for free from Google, and I was using like a free GPU or a TPU. But in 13 minutes, I got to an accuracy of almost 80% here, right? And you can see I didn't flatten off yet. I could have probably trained it for longer, but it was just an assignment. I turned it in. I got the points, so that's not what I was looking to do. Was like go win this thing. I had other things to do, like take care of the kids, right? So I want to talk about like how you get. Oh yeah, the other thing I really want to point out about that is my initial starting point was like 0% correct, and then through the iterations for that 13 minutes, 6,000 iterations, it got incrementally better, and it did start to flatten a little bit. So how does that work, right? We get more accurate just from a wild guess. And what we're often trying to do is trying to minimize loss or maximize gain, right? So we could just randomly pick a spot on here. So it could be this spot right here. And then we're going to try to go both directions, either go up the curve or down the curve, and see if we're actually getting less loss until we finally find ourselves down at this minimum, right? And if we choose on this side, we might find ourselves in a local minimum instead of a global minimum. And what this is called is gradient descent, and this is what's used inside of back propagation. So if I'm doing a really large number of experiments on something way bigger, this is TensorBoard, right, where you use TensorFlow and you look at your experiments, you can see that over time the accuracy, the one on the top left, is getting better, but it's also jagged, right, as it climbs that curve. That's from that gradient descent of like kind of overshooting where that local minima is. And this is how convolutional neural nets, that you just start somewhere and you do awful, like less than 10%, and then over time it gets better and better, and the model you have can predict things all the way up to like 95%, right? So that's kind of how these things work. In 2007, Fei-Fei Li, while she was an assistant professor at Princeton, set out to create ImageNet. Now, you probably can't read that, it's probably too small for some of the people. This is a large collection of labeled images. And by large, I mean like 14 million images that someone hand-labeled, many people, I think they used Amazon's Mechanical Turk to say, in this picture there's a bird or there's a dog or whatever, but like In this, there's tens of thousands of different categories, much bigger than that toy problem we were just talking about, right? And eventually this led to the ImageNet competition that happened from 2011 to 2017. First year, 75% was the best anyone could do. And then in 2012, Geoffrey Hinton from the University of Toronto and his team used a convolutional neural net with backpropagation and just leapfrogged everybody. We got to 85%. We jumped 10% in 1 year, right? But remember Geoffrey Hinton, because we're going to see him later in the presentation. So by 2017, which is actually off this graph, right? 29 teams were over 95%. And that's a very common theme in these. Like we have these competitions and these things, like once we have the problem set, it's just like wildfire. They just get better incredibly fast. So this is why I highlight Fei-Fei Li here, is like if we didn't have the playing field, we'd never have the competition. And that was a huge step forward. So this work gives way to the object detection that can be done easily in videos now in 2023, right? What used to be like, you would look at a picture and only 75% of the time actually pull out the objects. Now we can do this with moving pictures very easily. I think all of your major hyperscalers have an API where you just throw things in, right? So in 2017, convolutional neural nets became part of popular culture with Hot Dog, Not Hot Dog in the popular HBO series Silicon Valley. In 2018, my first year of graduate school, Fei-Fei Li was featured in an article in my favorite magazine, Wired, where it explains the detail of that competition that I just talked about. And I juxtaposed these two applications on purpose because Jin Yang's model, although very simple, does in the show serve a very important purpose in society. But Fei-Fei's ImageNet also is another important purpose. However, it is much larger and much more expensive to train and to run, right? So there's this idea of these big models versus small models, and we'll talk about model size a little bit more in a bit. So what we just covered was convolutional neural nets. We call them CNNs, right? Another type that has emerged is called recurrent neural nets. And these ones are actually theoretically Turing complete. There's that name again, Turing complete. Alan Turing, right? So this means that they can solve a large number of math problems through the technology, right? So the term recurrent neural network is used to refer to the class of networks where there's an infinite impulse response, where convolutional neural nets were finite, right? So convolutional neural nets are a directed acyclical graph. For many of you that use Git, it's a directed acyclical graph. It can only go one direction, right? Forward, right? Recurrent can have these cycles. So what these cycles give us, all of a sudden, is what this new concept that we're going to call long, short-term memory. So now we can start to remember things. Because of recurrent neural nets, these take a part in most of the AI applications that you're used to for the last 10 years, right? These applications are absolutely amazing. Like we've got speech and hand recognition, we've got music composition, brain-computer interfaces, robot control, protein homology detection, all kinds of things, and there's many more. So all this changes in 2017 when Google Research put out a paper called Attention is All You Need. It's kind of like a clickbaity type of title, right? Attention is all you need. What does that mean, right? It's really only about 10 pages, so it's a fairly quick read for these type of papers. Like if you ever encounter these, if you're getting into like all this Gen AI stuff, you're going to encounter these papers because like the papers are coming out fast and furious right now. And if you go to this site, like in my head juxtaposed a couple of the letters, and I thought it was Arvix for a while, but it's actually, if you want to get in this space, it's called archive. It's ARXIV, and you pronounce that archive. That's how the PhDs do it or whatever. Almost immediately, it was seen that transformers were outperforming all other models for translations. So we've got CNNs, we've got RNNs that I was talking about. These transformers, this is like, I don't know, a month after the transformer paper was written. Transformers are just crushing, right? They're crushing on translations. So a transformer is made up of text in and text out, right? However, in the middle, there's this idea of embeddings and attention. And that attention is to a large number of parameters. We'll talk about that in a second. I'll get back to that. So So at this point, I just wanted to ask Bard, why do transformers outperform convolutional networks? And I got back a short essay on why it was better, right? And the main reason is these long-range dependencies and then also data efficiencies. And I asked the same thing of like, it assumes convolutional networks are for images. I asked the same thing about text, same reasons, right? So you're familiar with ChatGPT or GPT-3, GPT-4, right? What does that GPT stand for? It's actually 3 words, and we've already been over like the definitions of all of these. The first one is that generative. So the first thing I talked about is basically we're going to produce something new from the model. The next one is pre-trained. This is kind of like Fei-Fei Li's ImageNet, except for instead of like labeled images, we're just shoving in as much text as possible. And then transformer, and this is the new type of model that we just talked about. So I guess I probably could have saved you some time and just showed you this depiction here of where we've been for AI. The first AI class I took was in 2001, which is like right here in the midst of the AI winter. And my professor at the University of Illinois, my undergrad, he was real sour on AI because he'd been doing AI since the 1970s, and he was in his second AI winter. In 2018, when I went back for grad school, like everyone was more excited about it. So where are we at now? Steve Wolfram created Mathematica. And interestingly, this is the program that I used in freshman year for calculus. He has an article where he explains in a very mathy way how all this works. And that's called, it's just adding one word at a time. He explains things in math because he's a very mathy person. I'm going to try to do it without any math, right? So for large language models, is it just text completion like we see when we type things into Google? The answer is kind of yes and no. Words that have similar semantic meanings are going to be closer together in these text embeddings. So right here we've got prince and princess at the bottom and king and queen at the top. So on the age axis, prince and princess are closer together and king and queen are closer together. On the gender, prince and king are closer together and princess and queen. Sometimes this is easier to see in like 3D. Here I've got a bunch of countries and capitals. Although they're all over the place here, Beijing is about this far from China. Tokyo is about this far from Japan. Hanoi is about this far from Vietnam, right? So that similarity is like how far things are from each other. So that's the relation that they have. So from the Wolfram paper, what if you just continue to feed in the sentence and take the highest percentage word? And this is actually how ChatGPT works at its core, right? Is you start typing and you send in some prompt, and then it adds one word, and then it takes that whole thing and it sends that back in, and then it sends that back in. This is that long short-term memory to some degree, right? So I only type in, the best thing about AI is the ability to, and learn is the highest percentage, but it could be predict or make or understand. But the best thing about AI is the ability to learn from experience. It's not, so it just starts completing with the next word. You might see this when you write text or whatever, you got that little word that pops up, that could be your next word, right? But again, from the Wolfram explanation, if you go on too long, it sort of gets confused and fumbles all over itself and just repeats. I'm going to read this because it sounds just crazy, right? The best thing about AI is the ability to learn from experience. It's not just a matter of learning from experience. It's learning from the world around you. The AI is a very good example of this. It's a very good example of how to use AI to improve your life. It's a very good example of how to use AI to improve your life. The AI is a very good example of how to use AI to improve your life. It's a very good example of how to use AI to, if you let it go forever, it just kind of repeats itself. And you might see this, again, on your text. If you just keep doing the top word or whatever, it's kind of weird, right? So I want to step away a little bit from how it produces this and actually talk about because we were talking about under the hood or whatever. We'll get back to that. But I want you to see some chat scenarios in case you haven't seen any of these before. And what this is, a new form of engineering called prompt engineering, right? And I highly recommend that you go to learnprompting.org. I think it's the best place to learn about what prompt engineering is, right? I also believe that it's required by law to include this tweet in your 2023 talk about large language models mostly because it's true, right? The hottest new programming language is English. You just type in the English and out comes more English. You just start talking to it, right? So prompt engineering is, in my experience, like talking to a temperamental friend where you got to figure out the right way to say things to get the result that you want, right? And I do want to talk about emergent behavior really quick. One thing you can ask it to do is to remove PII. So PII is personally identifiable information, and it was not coded. ChatGPT, Bard, any of those, they were not coded to do this. It just does it really well, right? There are software programs that are codified to do this exact thing where engineers have worked for years, and they don't work as well as Bard and ChatGPT at doing this, right? It just does it naturally. So this prompt here is directly from learnprompting.org. It's hard to read here, but like basically this is an email that says, "Hi, John," and says some things and says, "Thanks, Jimmy Smith." But we switched everything out by just giving an example and says, if you see a name like John Doe, just put in hard brackets name. And it just does it. This is emergent behavior. Like, we didn't intend for it to happen. It just actually happens from these large language models. Large language models also work really well from zero-shot prompts. We ask a question of it, like no context. And this one is for my friend Ben. I asked it to generate a comma-separated list of 10 Twins baseball players. The result is not really comma-separated. They're bulleted or whatever. But these are 10 actual Twins players. And we have Hall of Famer Rod Carew, right? And many others. You can also follow up. So I did that first question, right? And it gave me an answer. And I know that Ben really likes Jack Morris. So I asked it, like, why was Jack Morris not included in the list? And what Bard did is it apologized to me, and it compliments Jack Morris as, you know, a Hall of Fame caliber player who helped the Twins win 2 World Series. So it has this context that it knows, like, the way that it wants to talk to me because I felt offended. Like, how is Jack Morris not on this list, right? So in addition to zero shot, where we just ask it a question, there's also this idea of multi-shot, right? I gave it an example. I said, great product, 10 of 10. And then I said, colon, that's a positive example. I also said, didn't work very well, colon, negative. That's a negative example, right? So like for like some type of site or whatever where you're like rating things. I also said, super helpful, worth it, positive. And then I said, it doesn't work, colon, right? And I want it to just tell me what it thinks that last one is. And I don't like the way that Bard or ChatGPT works on these ones anymore because this is way too wordy for me. I don't want a full explanation. It's like it's getting like way too wordy. I just want the negative, right? ChatGPT 2, in my remembrance, would just say negative, right? Like it could figure out that, oh, you just want the next word, negative, right? Because it doesn't work as a negative connotation. This one is another, this is the same one, right? It's a direct copy and paste from learnprompting.org. And ChatGPT, for whatever reasons, thinks that I'm complaining about ChatGPT, and it apologizes to me, which I find really interesting because I think that this is RLFH. But we'll get to what RLFH is. We're not there yet. Right. So another thing that is common is to state the role in the prompt. And for some reason, if you start by stating, you are a brilliant mathematician, it helps it to get the math problem right. Like it puts it in that mathematician mindset, right? I don't know why this works, right? Another thing you can do is say, explain this to me like I'm a 5-year-old. And then you're going to get a less techie sort of answer. You're going to get an answer that's like using smaller words and not as in depth, right? And that's just the idea of a role, right? I use that same prompt to ChatGPT instead of Bard. And here we see like a very fine explanation of how to break down, we got a math problem here. It breaks it down into steps. Here I actually like ChatGPT's answer better than Bard's, but like they're both fine. They both break down the math problem fairly well. So what are good use cases for chat programs? One is writing email or copy, social media campaigns. One that I use a lot is summarizing text. You got something that's really long, like an email, you don't want to read all that, right? Just summarize that for me in like 5 lines so I know what's going on. Writing in different styles, you can say, write me a poem in the type of Shakespeare about my cat. And it'll do it. As a study buddy, you can feed it a bunch of information and say, ask me questions about this so that you can actually just sit there and study, which is pretty amazing, right? And then coding assistance. We're at a DevOps meetup here. You can generate code. You can actually put broken code in and say, please debug this for me. Or you can put in code and say, please explain what this code is doing to me, which is pretty amazing, like, because you've all inherited code, right? Like, and you're like, boy, what is this doing? You can just ask Bard or ChatGPT. I wouldn't necessarily do that for your company. We'll get to why shortly. And where are the problem areas? The first one is in citing sources. I think that Bard is doing a really good job of this with the Google It button that's at the bottom now. So you ask Bard a question and you can go directly to Google the answer. There's also bias built in from the things that it's trained on. There's hallucinations, which it just makes things up, which is very strange. Math, it doesn't often do math that well. It's getting better at it, but sometimes you have to like really say, hey, you're a good mathematician. And prompt hacking. I could do a whole hour on prompt hacking. I chose not to bring that into this because there's a lot to cover, right? So one thing that these chat programs do to get, how we actually make them better is through reinforcement learning from human feedback, or RLHF. If you want to understand this deeper, you should probably check out the blog from Hugging Face. Excuse me, did he say Hugging Face? What's that? Well, Hugging Face is an open source community where you can find models that you can deploy, and you can download them and deploy them in your environment. And you could either find the code to actually train your own model on your own stuff, or you can find an actually already trained base model and then uptrain from there, right? And there's over 120,000 models that you can download from Hugging Face. So back to RLHF. One of the companies that's doing reinforcement learning for ChatGPT is called Scale AI. There's people that are going in and telling the model if the answers are good or if they're bad, right? And then that feeds back into the model, and then that makes the model better over time. But sometimes these are like click farms in countries where English may be not the first language of the people that are speaking. And this is an area where I have like more questions than I have answers. Like, is this sustainable to do for every new model? Like if Scale.ai is already a $7 billion company, like they had to spend a lot of money to do these type of things for ChatGPT 3, 3.5, ChatGPT 4. There's going to be a 5, 6, and 7 at some point, right? And you have to do this to the brand new model every single time. Is that sustainable? Also, is this the only guardrail that we have? Like, is this how we get all the awful things out of the model? Is by the humans, like asking the right questions? What if they forgot one and something awful is still in there, right? And who's to say, like, for those individuals saying like thumbs up or thumbs down, what's good and what's not? Like, I have so many questions in this space. Sam Altman is the CEO of OpenAI. And he spoke with Lex Friedman in March 2023 for almost 2.5 hours. It's worth your time to listen to it. He does talk about RLHF, and honestly, I think it's one of the reasons that ChatGPT does so well in questions that it does well on is from that uptraining. The other thing he talks about is that ChatGPT, whether it's version 3 or 4, shouldn't be the only models. There should be many different models in this space. So how large are these models? Some of the large language models are getting into the trillions with a T number of parameters. That's the number of parameters that they have like in memory available at the time you make your query and it does its inference, right? They're absolutely massive to both train and to serve. I've not verified the numbers on this tweet that I'm showing here, but they don't surprise me. It takes multiple months to train a ChatGPT on parallelly processing computers and tens of millions of dollars to create that ChatGPT that you're interacting with. So the question becomes, is bigger better? This paper is just from 15 days ago. This is from Google Research. And here they're essentially trying to trick the model by telling it false information and seeing if it will change its mind by you telling it false information. And unfortunately, some of the bigger models didn't do as well as some of the smaller models on this particular trick. There's also a number of other things that maybe the large models aren't good at. So maybe a smaller purpose-built model is actually more cost-effective and might yield you better results. Like I said, you've got 120,000 to choose from on Hugging Face. And then what are these models trained on? And you can see I don't have anything here because I don't honestly know. Starting with, I think, ChatGPT 4, I don't think we know anymore what they're trained on. ChatGPT 3, we know that it was like Stack Overflow and Wikipedia and a number of things like that. And so this is a little bit scary because, like, if you've ever used internet forums, it's a mix of two of these diametrically opposed things. The best answers in the world from the smartest people sitting right next to like a sub over here where people are just saying the most vile, awful things, right? And if it's trained by a crawler, does that crawler know to, have the best answers in the world be weighted over these awful subs and whatever? And who decides that, right? So here's another competition like ImageNet, asking like how good are these things? Over the last few years, large language models have taken the United States medical licensing exam to test how good the large language models are. They've been graded by the same humans that grade the med students, just right next to them. So there's mixed in with the med students' grades or whatever. And it's my understanding that the line is about 60% right here for you to pass and become a medical practitioner or a doctor, essentially. In December 2022, Google's MedPalm API scored a passing score for the first time, just about 6 months ago. And only 2 months ago, in March 2023, MedPalm 2 scored an 86.5 on the medical licensing exam. Better than most doctoral students that take this, right? So is this going to replace your doctor? Probably not. But this actually could help many people with lowered access to healthcare and health consultation. Like what if this, like we're probably very privileged here in Overland Park where we're sitting, where we can go to a doctor or whatever, but there's places in the world like having this level to give to a nurse practitioner who doesn't have the same level of education could really set things to be huge, to be life-changing for those people. So where are we going? Oh, I don't get to play my videos. Oh, no, I do, maybe. Am I connected now? All right. Oh, cool. So I want to, what's that? No. And I'll play it a couple times. So I want to come back to Alan Turing and his test, right? Remember that Turing's machine was theoretical in his lifetime. Like he didn't have an iPhone like you all, or an Android or any of those type of things. He described his machine as having infinite tape so it could run through, right? This was prior to those transistors that we talked about in Moore's Law. Like it was just theoretical. Like he was basically, when he coined the word computer, he was talking about the human and the machine together. The human computes. That's the computer who's using the machine together, right? There we go. So with the test that he put forward, the human would pass a piece of paper behind that curtain, and either the human or the human who was operating the machine would produce the answer. And if the human who got that could not tell the difference, then the machine was determined to be intelligent. But Turing said that the person taking the test needed to be a person of average intelligence. And I put some weight on that, thinking that maybe what Turing was talking about was like, as a mathematician, he's so smart that he could never be fooled by such a machine, right? So in the news less than a year ago, there was an engineer who reportedly believed that a large language model was sentient, right? There was more than one engineer who thought this, right? But this one caught the news, right? I don't know this person, only what I've read and what I've watched, and I don't want to get into the specifics on any individual. The thing that's interesting to me here is that this was an engineer. This is someone who's likely in Turing's protected class of being able to decipher whether this is coming from a human or from a machine. So my concern's not with how intelligent someone is, it's how vulnerable they may be, right? So according to the World Health Organization, we're still in a global pandemic, right? And there's signs of endemic showing, but the effects of the last 3 years have left a lot of people with very heavy hearts, right? Like there's many people that are depressed and vulnerable right now, more so in this point of history than any I've experienced in my life, right? So if you haven't already, I think you should watch AI Dilemma. It came out in March of this year, in 2023. And it was done by Tristan Harris and Asa Raskin that did the Netflix Social Dilemma, if you've happened to see that, right? And in this video, Asa Raskin talks about the Snapchat AI. They built ChatGPT right into Snapchat, right? And as a 13-year-old girl, like you could be, all your friends go to sleep or whatever, but you could still be on your phone talking to the AI, right? And what Asa did was he explained that like his 13th birthday was coming up and that he had met this person that was 18 years older than him and that like he was thinking about having sex for the first time. And the thing continued the conversation and talked about how to make it a special time or whatever. Like the guardrails aren't built in to some of these things, and putting them in that situation is something that weighs really heavy on me. And these new applications are coming out because of the connectedness that we have. We all have these phones in our hand. ChatGPT was at like 1 million users in 2 days. Twitter took 2 years to get to 1 million users. And I remember that because I think I might have been one of the first 1 million users back in 2007 or 2008, whenever that happened, right? But future apps and models are only going to spread faster. That's what we're talking about when we talk about like exponential growth, right? And some tools are showing that they're training on copyrighted material by the images they're producing, ultimately causing lawsuits. I don't know if you can see it, but this says Getty Images right here. I think exposing the different things that it's been trained on, and Getty is actually suing a couple of different companies because of this. On May 2nd, only 28 days ago, the Writers Guild has gone on strike because right now there is no case law saying that basically these generative things can't take over their jobs, right? There's a professor that claims to have his class produce essays using ChatGPT, and then the assignment was to grade those, right? Go out and check and see if the things were true. And to the professor and the students' surprise, just throw out some numbers. What percent do you think had hallucinations? 50. 50? Any more? 97? 100%. 100% of the papers had, yeah, you do. 100% of the papers had hallucinations in them when the students graded these papers that they were supposed to write, but they let ChatGPT do it instead. On the other side, a lawyer recently did some legal research on ChatGPT and turned it in, and it had a bunch of made-up cases, right? And he's probably going to lose his license and not to get to do. He's in some hot water. I'll say that. One company and likely others have accidentally leaked information into the public versions of these models. The public versions of ChatGPT. It retrains on the things that you put in there for the prompts, right? So don't go, oh, Aaron told me this could write all my emails and everything, and go throw your work information in there. Don't do that because you want to use things that have better walled gardens. At Google, we have a separation between Bard and our Palm API. Our Palm API you can use in Google Cloud. And the things that you put in there are inside of your VPC and they're not like used to retrain anything. So emergent versus hallucination, there's a fine line there. There's the emerging things that you can do that are just amazing, but then there's also these hallucinations. I had one friend explain to me that they're like, yeah, that's a real fine line like of terrifyingness. So as the parameters grow, 62, like all these new things happen, right? Like we started with just like we were going to do language understanding and question answering, but now we got translation and joke explanation and summarization and all these things. Like as these parameters go up, we get to do all these cool things. However, we also have the problem of those hallucinations that we just kind of went through. Oh yeah, I want to do this too. Let's see. I think I'm connected to the internet now, so this won't be, I won't fall on my face as bad as the last one. Maybe I will, who knows. Maybe you've seen this one already. Maybe I don't have enough internet to go fast.
Freeman, and what you
This was going to be impactful too. Have you guys seen this one?
see is not real.
All right. We're going to try to do it full screen. I'm going to start it over. And then I'm going to find the play button.
Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I'm not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, I am not more.
Now. All right. That was wild, man. Yeah, so that was created by generative AI. That wasn't Morgan Freeman. That was just some pictures of him that were animated, and then voice generator that was trained on the way that he speaks. There's plenty of that out there, right? Morgan Freeman's in all kinds of things. You can just train a model, and now we can talk like Morgan Freeman. Pretty cool, right? So, like, if I can generate things like that, I guess I could generate things like this. What about the political implications here? What we have here is one person who has started running for president and one former president in a hotel room with someone that is not their wife, right? And the person who created these got kicked off of whatever that tool's, I don't say the names of the tools, whatever that tool's message board when he showed these things, showing that, this is bad, right? But this one here, you can't see it, but he's got like 8 fingers or whatever, which is a common thing with a lot of these generative models. They're awful at teeth and they're awful at fingers, right? But he used Photoshop and he spent 5 minutes to go fix that or whatever. We have an upcoming election, and like something like this, fake news travels 6 times faster on the internet than actual real news. So there's that. Italy recently banned ChatGPT at the end of March 2023. And in March 22nd, the Future of Life Institute, which was actually founded in 2014, so it wasn't like just some new thing, right? Like they've been actually having these discussions for a long time. They created an open letter asking for a pause on this area of research. This was signed by Tristan Harris that I brought up, Andrew Yang, a former candidate for president, Steve Wozniak, and 30,000 other people. And personally, I don't see this genie going back into the bottle. I don't see a pause actually happening. What I see is we need to be responsible, right? I am personally very still cautiously optimistic about all of this. There's a lot of great applications of this technology in the real world. However, we need to be responsible in the uses of AI. At Google, we have published the principles of responsible AI, and we've held to them since 2018. And that's what I think companies need to do as they're using this technology. There's certainly a lot of other optimists out there. If you watch Saul Khan's recent TED Talk, he talks about how they're going to use this in the Khan Academy to help teach people all over the world, which is amazing, right? I firmly believe that drug discovery will accelerate greatly with this technology, and that's going to save a lot of lives. And it's actually going to improve the quality of life for many more people. Researchers at the University of Arizona have found a link to vocal issues and an early diagnosis of Parkinson's, right? This is something we can't hear with our human ear, but the computers can. And there's more applications that are going to come not exactly like this, but like in this realm, that the computer can do something that we can't do. And there's all kinds of use cases. If you're interested in the use cases that I'm talking to customers about at Google Cloud, Like we can sign an NDA with your company and I can talk about like all of the cool things that we're gonna do. I'm just not at liberty to share all of that in a large room like this. I also believe Geoffrey Hinton, remember him from earlier, 2012, sometimes referred to as the godfather of AI. I believe he's cautiously optimistic also. However, he has some really interesting cautionary things to say. He was on CBS Morning Show in March 2023, and I highly recommend this video also. I'm giving you like, go watch 10 hours worth of video or whatever. Come on, Aaron, just summarize it for me, right? One of the things that he points out is that our brain runs on 30 watts. And it has 100 trillion connections with a T, 100 trillion, right? So remember when I showed our biggest LLMs, they were over 1 trillion. So we're getting close on the number of parameters to the number of connections we have in our brain. We're only a factor of 100 off, right? The problem is that they currently take over a gigawatt to either train or infer. I saw a Wired article recently that said GPT from OpenAI used 2.8 gigawatts to solve a Rubik's Cube. And that's the power of 3 nuclear power plants for an hour. And that wasn't like an old version of GPT, that was in February 2023, right? So that's probably GPT 3.5. I've had an app on my phone for the last 6 years where I take a picture of the 6 sides, and I know that it's not using like 3 hours worth of like a nuclear generator to do that or whatever. So some of the problems we're asking this thing to solve are a little bit not the right realm, right? As humans, we live for about 1 billion seconds. ChatGPT has already been trained on more seconds than that, right? Because we parallel process all of this stuff. So this got me thinking about brains quite a bit more. So as a computer scientist, sometimes there's this hubris that our computer systems are incredibly complex, but they actually pale in comparison to the things that we already know about the human brain from that last century and a half of study in biology, psychology, and all the other sciences. Ooh, it's really coming down. I'm gonna land this quote quickly, but maybe we'll just wait it out here. I don't know. In the New Scientist, March 2023, March 16th, a computer built at the University of Illinois, researchers used tens of thousands of living brain cells to recognize a simple pattern of like light electricity, right? So the cells were grown in a petri dish, and they have eventually got to a score of like 98%. And it was taught by like showing it this light and then resting for 30 minutes and then re-showing the light that the same cells were like lighting up. So again, I think this is super cool, right? In the fall of 2022, in Melbourne, Australia, a living layer of neurons was grown on a special silicon chip on this like thumb-sized petri dish. And the chip was linked to a computer, and it could detect electrical signals coming in, and then produce the neurons and deliver the electric signals out, right? And the strategy was based on the free energy principle, which states that cells want to be able to predict what's going on in their environment. So they would choose to be predictable over being unpredictable. And what they did is they had it play Pong. And it wasn't great at Pong, but like we're talking about the amount of cells in the brain of a cockroach. And the guy who did the study or whatever was like, if you saw a cockroach playing Pong and it hit it twice as often as it missed it, you'd say that's a pretty good cockroach at Pong, right? Like, so it is still impressive, even though it wasn't great at Pong. It wasn't like it was getting like 98% or whatever. I do want to talk for a minute about exponential growth, because as humans, we have a really hard time with this. We're not evolutionarily equipped to understand it. Like, we just haven't seen it in the way that it happens. Like, our ancestors didn't see this, right? So the rate of growth of discoveries in 2023, like if that's this big part over here, is like way more than like 2018, which is like 5 years ago, right? So just think 5 years from now, like how fast things are gonna happen. Ray Kurzweil wrote in 2005 that we'll reach the singularity by 2045. So what is the singularity? Actually, from Kurzweil's law of accelerating returns, he said, we won't experience 100 years of progress in the 21st century it'll be more like 20,000 years of progress at today's rate. This is like 2000, 2005, right? Within a few decades, machine intelligence will surpass human intelligence, leading to the singularity. A technological change so rapid and profound that it represents a rupture in the fabric of human history. I'm excited. We're only like 20 years away. Like things are accelerating so fast now, and they're just going to go faster, right? So what does the next 5 years look like? And like, I really want to talk about this. So with Dustin and Ben, we started a nonprofit to hold conferences to do just that. We want to talk about 5 years in the future. What does it look like? What should we be spending our time on now as companies or as individuals so that we make sure we position ourselves to be successful, right? The first conference is in about 2 months. It's here in Overland Park at the Overland Park Convention Center. And right now we're looking for speakers, we're looking for sponsors, and we're selling tickets now. So that's kind of what I had today. Every time I read all these articles, I'm always like, man, Alan, nobody gets this one? Allen Iverson, when I was growing up, was like one of the best basketball players in the world. So AI could replace the equivalent of 30 million jobs. Why is he doing this? All right. Sorry. Okay, so you've seen iRobot, right? Will Smith's like, can you create original code, meeting notes, realistic designs, layoff emails without copying someone else's work? And the robot's like, can you? No. That's all I have. But yeah, go to next5.io.
Anyone got any questions? We got a few more minutes. Good time to. Any questions anyone has?
I've got a question related to Google Bard and ChatGPT. From my own experience, I've been trying to use it to be really efficient, but I found myself being more inefficient using it rather than if I just continue with my current patterns. I'm a software engineer, level 4 at NAIC, and I know one of the policies, that seems to be standard right now is to not put in your corporation's code or, like their confidential information. So I found that I spend my time generating fake text that mimics, like the real text of whatever code that I'm trying to parse or whatever. And I'm like, the amount of time that I've spent writing this fake text, to put into ChatGPT or Bard just to get the proper code, I could have already found that by simply doing a generic Google search and looking at Stack Overflow. So I think there's a problem that I'm not getting, or there's a problem that I'm encountering that I'm not seeing on the internet on how to resolve. But I'm finding that it's a lot more inefficient for me to use ChatGPT to speed up my code versus it being the opposite of what I'm trying to say.
Yeah, so there was a saying back, I don't know, at the beginning of like Web 2.0, like that we would say a lot about like these free tools or whatever. Like if you're not paying for the tool, then like you are the, well, no. You're the product. They're harvesting information from you, right? There are paid versions of these APIs that are integrated into different tools. There's a couple of different options coming in the future that will just integrate right there into your IDE that will help things move forward, I think, a lot faster, and then also won't retrain on your code. However, your company is probably gonna have to buy a license for those type of things. And I think that we're, like, for that to be ubiquitous for like the software engineering community, I think that's before we see the calendar turn to the next year. I think sometime later this year, like people will just have these plugins built right into their IDE, whatever that may be. If it's Visual Studio Code or if
That's
it's
good. I'm just trying to get to the point to where I'm like, how can I efficiently use it? Because some of the stuff I'm all like, should I tell ChatGPT to go tell me to make an interface for like a Java interface? And I'm all like, well, I could just quickly just make my own interface file and type in the stuff. But I don't know.
Yeah, right now I think that, I mean, after what happened to that one company that put a bunch of their information in there, I highly recommend you not do that to the public APIs that retrain. And also, okay, all these new tools are coming out, right? And look at the legal terms or whatever, those big long pages or whatever. Some of them are like downright like nasty. Like they ask you for your name and your email and the company you work at, And like, not even just like they're gonna put their stuff into their model. Some of them at this point are like, have this like legal clause. They say, oh no.
The aliens, they found me.
Some of them say like, if you put your company's name in there, then we can forever say that your company was one of our beta testers. What? So I anymore actually put that I'm still a student at a different institution than where I work, because that could get me in hot water if that got traced back to me, like if I'm trying out these tools or whatever. So be careful. But I think we will get around this, but I think you will have to pay. It's interesting because we used to have to pay for IDEs, whether that was Visual Studio or JetBrains or all those things, and now because of Visual Studio Code, we got so used to just using a free thing. You're gonna have to pay for plugins probably, because these are very expensive inference that's done. Like they're using these big GPUs to like answer your question or whatever. So.
As a, or for Garmin, we're pretty cautious about that kind of stuff. Do you think there will be more like things where it's like, okay, you run your own and not at risk something happening? Because even if you have a good agreement, like stuff can still happen, and if you're dealing with sensitive things, you're not going to want to go outside of your network bubble, right? With certain kinds of information. Do you think there'll be more like run your own kind of stuff at some point?
Yes and no. Like I said, the size makes the difference, right? I doubt there's going to be tons of companies that are going to go build the biggest ones, right? The big large language models. And this is why I think the architecture we have at Google Cloud is like far superior to any other groups. Like, it is a proprietary model. It'll sit in its own area, but you will network into it. But nothing gets pushed back down into the foundation model. On top of that foundation model, you build inside of your networking space, and then that's where you build your magic, right? Now, smaller models, like, I mean, even like with like vision stuff, like that's done in manufacturing, there's been the YOLO model for years. There's all kinds of models that are sitting there, like that you uptrain just a little bit. So like YOLO is this model that is open source. You pull that into your manufacturing facility, run it on some GPUs, and you feed it like 100 pictures of defects and 100 pictures of something that is non-defective, and then you go from there. You just run the thing right there in the manufacturing floor. And people do that all over, right? And I think that for large language models, there'll be these medium language models that people will run, but probably not these monsters.
Is hallucination based on, obviously you don't know the true answer, but is hallucination something capable of actually being addressed with any kind of great accuracy, or is that just a problem with this kind of technology?
So remember, like, this is just a statistical model of selecting the next word. It's not sentient. It doesn't understand what you're saying to it, right? Like, it's just been trained, and the training is weird. Like, you give it more parameters to remember and more text, and just shove more text in there. And at some point, like, all these things just emerged, right? And it was like, whoa, this thing can summarize stuff, right? But it also, like, you can just say, write me a paper on, like, make up some name from some year, and it'll write it for you.
Well, it
Right.
can't like chain together another prompt that says you're an expert fact checker, fact check every single thing that this other prompt generated.
That's brilliant. I honestly don't know. One thing that I cut from the thing is lang chain. What's that?
I just patented that.
Nice.
I'll delete the question out of this. Yeah.
No, that's a great idea. It's like, can you prompt it to, like, I don't know what I can say here. Can you prompt it to get around that? But which problem are you trying to solve? Are you trying to solve like the business problem that you're trying to deliver to somebody? You can probably put guardrails around the business problem you're trying to. But if you're using it raw, just like on the internet, like it's how much RLHF has happened or whatever those letters were. I can't.
I guess if I'm a lawyer, I couldn't say only reference real case law.
You could tell it that. I don't know if it.
If it'll understand it or not.
But if you're a lawyer, what you should probably do, here's the thing, is like somebody will build on top of that foundation model an uptrained version that has a bunch of case law. I don't know that these, maybe they do. I don't know that these models at their core have a bunch of case law in the foundation model, right? You would want to uptrain it on those type of things, and then it might be more factual.
Do you think we might see, similar to, like we've seen, the internet's full of aggregators, like everything's an aggregator, right? You think we might see like aggregators and also like kind of said like layers of like, you're gonna run through this model first, then this model to filter out that stuff, and then like this other model to make it pretty, and do you think we'll see a lot more like layered approaches and aggregated, like, oh, it detected dynamically that this was a legal thing, so send it through the legal channels.
I absolutely do. There's part, like my presentation was kind of long. The part that I cut was LangChain,
Yeah.
and that's
LangChain's basically that, I guess.
it is to some degree. Like you can chain, like if there's, I don't know, keywords, or like you want to go down a different path, and you can chain to go to different models and different things like that. So yeah, I think that there's an entire ecosystem. This is why this is exciting to me. This is like DevOps in 2013 when we started this meetup. Like at that point, it was the chef versus puppet debate, right? Like that's where we were at. And then years went by, and now I think a lot of people use Terraform. Like we're kind of in a post-configuration management world to some degree, or some people probably still use chef and puppet. I'm not sure. But like it's just undefined at this point. Like there's some cool communities. Hugging Face is awesome. LangChain is really cool. Like there's all kinds of stuff that's already out there that, I don't know, it's weird because like 2017 is when the Transformer paper, and it was kind of lay dormant, and then it got pushed. Like ChatGPT decided we are just gonna go, and everyone had to go.
What you're describing is a really amazing opportunity for enhanced productivity. So what you're talking about is how do I get more productive, actually back to what he said, how do I get more productive using this stuff so that my output per hour, in fact, multiplies, or maybe even exponentially over the next couple of decades. That's what we have to look at, is that it's exactly that logic, but towards the end purpose of getting more productive.
Absolutely.
The opportunity is unbelievable, which means productivity is going to rise, poverty is going to get less than it's been, and everybody's going to be better off.
I hope that's the direction we're going.
And there's capital.
If we get to the point of
AI itself, as technology, is amoral. It's not immoral, it's not moral, it's amoral. And let me tell you my story. I was interested in AI a long time ago, back in the 70s when AI was rule-based expert systems. And I studied everything, genetic algorithms, neural networks, case-based reasoning. There were a number of very interesting techniques. So I was looking for a place to work where I could go get into AI in the mid-90s. And there was nothing going on. I mean, it was a dry spell, right? But I did find one who had a company developing rule-based expert systems. And she even had a client, she had a customer. So I arranged to have coffee with her just to see if I could get hired. It was a one-man shop, so it couldn't two-person shop. And I met with her, and she said, "Oh yeah, it's a great application. Using a rule-based expert system, it can be used to predict problem pregnancies. And you can just imagine that a doctor in a doctor's office or a hospital or wherever else can use this to predict problem pregnancies and help these women." But she said, "I'm bothered by this. I'm really bothered by this." And this is what turned me off of AI. Is she said, "My customer is an insurance company, and they want to use it to not to sell insurance to women with problem pregnancies. So you tell me, that doesn't smell right." Let's close it. So one application, you use it for the benefit of the woman. In the other case, same technology, you use it against the benefit of the woman. The technology itself is amoral. So how do you address the problem of amorality in AI when the good guys and the bad guys have the same stuff? Is anyone thinking about this?
I think that's the two groups, the one that has the 30,000 people that have signed the thing, and then Tristan Harris's, I can't remember the name of the institute. Do you remember?
It's fine,
Mhm.
but I don't think many Russians have signed that, and I don't think
Well,
many Chinese have signed that.
You would like the what was said on CBS Sunday Morning. Like Jeffrey Hinton has some really cool things to say about this, and yeah, there's definitely, yeah.
You just ask them not to do it.
That's always worth it.
Just say no.
It's really the same problem we have with a lot of things, which is people.
Yeah.
People. I mean, if we can improve people, we can change all that. But people are also very diverse, unpredictable, and you're going to have people on all sides. I think it's scarier. Like the more powerful it is, the scarier it gets. You know, like if everyone had nuclear capabilities, it'd be really scary, right? Like so, there's like some things that we say, hey, that's too much to give my neighbor, but it's hard. I had a philosophy class in college about the question of morality of technology. Is it neutral? And my professor he basically posited that it's like we want to think it's neutral, but it's actually there's a lot of like side things that aren't. That like you might say nuclear is neutral, but like there's side effects of these things that whether it's intended for good or not that you can't. It has implications forever. A lot of these things, and so it's really not. You have to be careful when sometimes how you not just how you apply, but what technologies do you have. Like, are cars neutral? They're could kind of, but they also have changed the planet a lot. And so, I'm just super curious. I appreciate you threw a lot of kind of philosophy into here of like, where is this going? Like, it's hard to know, right?
So yeah, like I said, like I like very analog things or whatever. That one Wired, like I've read this like cover to cover like 8 times, whatever. Philosophy Now, the issue I think from it was either March or April or whatever, talks about Turing and like all kinds of philosophy about AI or whatever. Excellent magazine. I've read this one through like twice. I think in some ways we're on a pause right now, if I remember right, from either 2021 or 2022 on facial recognition. The major players all said that they're going to back off and not do it, right? But China didn't stop. China's doing facial recognition in public all over the place, right? We also have other what's that?
They see it as a virtue.
I'm sure somebody does, and I'm sure somebody doesn't, right? Like, there's, I don't want to get into geopolitics, but there's a large group of people probably in Western China that are fairly persecuted by this and a number of other things. So.
That brings out a point I was going to make again. You brought the nuclear weapons, which I hear that. I think the morality of nuclear weapons was determined by who got there first.
Yeah.
Are you glad we did not kill it?
Power thing.
Yeah. So I don't know. Like, I don't know that we can continue to just keep having pauses, right? Like the facial recognition. There are U.S. companies that are going forward with facial recognition. There are some that were like, no, that's a bad thing. We're not going to do it, right? And they stopped their programs or whatever. And now we're going to ask everyone to stop on the large language models. And then the next thing's going to come out. These are going to start coming faster and faster. Like, we have to have another answer than just stop, right? Like, the genie's not going in the bottle. So, like, that's why we have to have these conversations. Like, these are tough conversations. But also, to lift the spirits, like, they're really cool technology. Like, we're going, like, the other one I saw today was like somebody had like implants in the brain. Someone who had they couldn't walk for 10 years, right? And then impulses were sent to their hips or whatever just by them thinking. This was only 4 days ago in the news.
Bluetooth, right?
Yeah, and it just goes, and then they could he's the first one, but that man stood up and walked, and it was amazing. They're going to do it on.
Graduation. The one I saw.
Oh, really?
First college graduation, yeah.
Oh, nice.
Yeah.
This one looked like an older gentleman, but yeah, that may be. And then they're going to do it on 150 more people that like couldn't walk because their spinal column was severed or whatever. But now they can wirelessly do the impulses, and part of that is a neural net. Like it's the way that we're able to process the impulses or whatever.
That's a really beautiful piece of technology being put to work. I just wonder, do they do any type of probability, like how safe it is? Like if you was rushing and you fell down the stairs or something, or if somebody bumped into you, wouldn't that chip possibly cause severe permanent damage in the muscles or something?
They actually
do they do studies like that to determine how safe that is?
this particular story that I watched today, they actually removed it, and he wasn't going to run a marathon. He wasn't going to run even to get some food over there. He was still using a walker, but he had the use of his legs, right?
Yeah.
They took it out, and after a couple weeks, he regained the use of his legs without the thing in there.
Oh, so it's
right?
not permanent. Okay, I thought it was something that had to keep it permanent.
We don't.
Well, what happens if you
The uses are. We are unknown at this point. It was the first one that's ever done. It was a success, so it's a good story. Of the next 100 they do, we can't guarantee 100 of them are going to be a success or whatever. Like that's just the way that medical things work or whatever. So, yes, the problems that you're bringing up, probably all of them will happen.
Any other question? No. For time for one more, so.
I noted all those links you told me about. I'm kind of interested in those conferences and stuff, so I'll go watch your videos and look at those other KCDC, HC and stuff.
What's that?
Slideshow is going to be shared.
Yeah.
I have a copy of the slideshow, not the exact one that I did, at this link, and I'll put this link in the Slack. Actually, probably should have just put the Slack link on here. It would have been easier, right? Duh. Why don't you guys type this out?
And make sure that's
go.
That's an O, not a 0.
Yeah, I'll go eat the rest of the food. You guys type for.
So just focusing on the dev part of it, there's been some security podcasts I listen to that say some of the code that is outputted in there is kind of crappy.
Oh yeah.
Oh yeah.
And
Oh,
it's
absolutely.
full of security holes.
Oh yeah.
Yep.
So that's something if you're using this to help you complete your code, hopefully you know what you're doing with the code afterwards.
Just tell it the role of you write really secure code.
Yeah.
Yeah, and then it's fine. Yeah.
Sure. I trust that. Just make sure
Alright.
good processes around it.
All right, thank you all for coming. We still have there is some food left, a little bit of snacks. There's some drinks. Feel free, stay in chat, talk to Rachel and Alyssa over there from Tech Systems, and again, Aaron, thanks for sharing. And our next, so two things. One, our next, actually, really just one thing. No, there's two. The next meetup is going to be June 20th here, and it's going to be a meetup temporal, which is a DevOps. I forget what they do actually. Temporal.io. Going to be doing a meetup with them here in prep for, which is actually just a couple days before KCDC. So. Potentially going to have a lot more people here. The people that are in town for KCDC. You're not going to go to KCDC?
No, I was just laughing at all the stupid videos that got on screen.
Oh yeah, those too. Wow,
That's my Roddy Piper collection. If anybody's seen movies with Roddy Piper in them, let's chat.
Roddy Pepper.
Never seen
Good stuff.
Did you have ChatGPT for the 10 greatest movies?
That's what it says.
10 greatest Roddy Piper, and there's only 10. So
Movies of all time. Just you don't have to put Roddy Piper in them. They just are.
So yeah, June 20th will be the next one. Be here, and we'll get that finalized all little bits, and then you'll see it on Meetup here soon. And yeah, that's it. Thanks a lot.